Hello everyone. This will be my recording for week 3. At first, I will start with your presentation overview. Then I will give a brief tour with the lab. So, taking feedback from the last week, few of the students have problem using the iCollege player. You Most of the people, and I also saw that. So, the video you can't forward or rewind the video. So that's why I decided to upload that in a different channel. So hopefully I will be uploading this recording to my YouTube channel. I will give you the link. Then you'll have to it will be uploaded in the same fashion and the way we did in the last week. But this time, instead of a video, it will be a link for you. So when you click on that link, you might prompt to you might see a screen that will say a warning, that will say actually that you are going outside of the iCollege. You can click, you can forward with that. It's safe because I'm giving the YouTube link, so you can proceed with that and watch the video. Having that in YouTube will help you to control, pause, and play the video anytime you want. So let's start with our PowerPoint presentation. So let's go to my iCollege section. Content. Okay, so one moment, please. Let me open my presentation file here. So yeah, so this is Lab 3 presentation. So let's start. So this week we will be talking about the troposphere. So Lab 1, you studied solar radiation and season in Lab 1. So you saw how solar radiation worked for different types of season in different parts of the world. Then in Lab 2, you studied the stratosphere. Specifically, you studied the ozone layer, and about how it's getting destroyed, and lots of other things in the stratosphere. This week, we will be studying about the troposphere. So, you've already seen that the troposphere is actually where we live in right now. So above that we see stratosphere. So last week we studied stratosphere. Now we are coming close to the Earth. So this will be the 3 research question for you. Let me turn on my pointer, laser pointer. Okay. Number one, how does the troposphere differ from the stratosphere? So, the first part of the lab, we will be talking about the difference between troposphere and stratosphere. Then, at the second part, or in another portion of the lab, how does the composition of the troposphere change with the change in altitude? So altitude means the difference in height. So the more you go up from the earth, the more your altitude will increase. So how the composition, like how the density of the air, how the moisture or any other content changes in relation to the altitude. And as for the question 3, we will look at the change of composition in terms of latitude. So how moving towards the northern hemisphere changes things for us, for the world, and how moving towards the southern hemisphere, how moving across the tropical zone, how moving across the subtropical region changes things, changes the composition of the troposphere. So we will study these types of things. So you can already see the difference in our weather, our environment, in our landscape. Like if you are in Atlanta, so you can see lots of greenery out there. And if you go toward the Midwest, or if you go toward in the Texas, if you look at them, then you'll see lots of like in Arizona, you will see lots of what do we say, desert like environment there. At the same case, if you not even in America, if you go out of the USA, you will see there are certain region of the world that has desert type weather, desert type landscape, and there are certain region of the world that has really tropical landscape, like lots of forest, and lots of different types of things. So that is the study of the latitude, how change in latitude actually change the atmosphere, change the weather condition, change in the composition and everything. We will study about that as well. So one more thing to remind you, this lab, particularly this one, has a few computational questions. So that's why it's really really important for you to follow my guideline, because last semester I saw some of the students were struggling with the mathematical computation. So I will show you how to do some of the calculation. And uh, if there's two questions for the similar question, I will do one for you, and another one you'll have to do that. So let's start with that. First, let's finish my presentation. Then you will be able to see those calculations when I will open the lab tour. So let's go to the next slide. So as with the research question one, this slide will answer few question of your lab. So if you look at the comparison between troposphere and stratosphere, if you look in here and there, you will see that nitrogen, you see nitrogen in stratosphere, nitrogen in troposphere, oxygen in stratosphere, oxygen in troposphere. They are the abundant one in both cases, and they are almost similar in both cases. So in terms of nitrogen and oxygen, there's not much difference, and these two are the abundant gas in both layer of the atmosphere. But if you look at the other one, so if you look at the ozone, that is the two distinguishable thing you will be able to see in troposphere and stratosphere. If you look at the stratospheric ozone, then you will see that is 0.0003% of the total composition of the stratosphere is ozone. Then if you look at that in troposphere, that will be 0.000005% of the total composition of troposphere. So you can see from these two that ozone is much less in quantity, in mass, in troposphere compared to stratosphere. So this is one of the distinguishable factor, these two layer and one another is a water vapor. So you can see water vapor in stratosphere is 0.0005%, and if you look at that in troposphere, that is 0.039%. Sorry, that is the carbon dioxide. Sorry, water vapor is 0.46%. So that is completely uh, hugely different than stratosphere. In stratosphere, there is only 0.0005%, but in troposphere, there is 0.46. So compared to stratosphere, that is a huge content. So why is that? uh, if you go to the lab, if you watch the introductory video by Mila, she will talk about that as well. Let me tell you, you see, the source of water is definitely the ocean, in our case in earth. So the source of water is ocean. So if you look at the stratosphere, if you look at the placement of troposphere and stratosphere, troposphere is close to the earth, so that means the oceanic content, the water vapor or particulates, that will be abundant in troposphere compared to stratosphere, because stratosphere is relatively far away from those oceans. So that is one of the reason, and that is the main reason for the troposphere to have more water vapor than stratosphere. So these are the distinguishable thing in these two. So you can see from these writing, in stratosphere we can find more ozone, in troposphere we can find more water vapor. So these actually answers probably two of your question for the lab. The next one, so probably this is the same thing that I've been talking about. Let's go through this again. Troposphere and stratosphere. Number one, troposphere has more of water vapor while stratosphere has more of ozone. I already told about that. Then nitrogen and oxygen are the two of the most abundant gases in the troposphere and stratosphere, and they are almost similar in both layer. Then number three is troposphere has relatively higher concentration of water vapor, particulates, and aerosol Particulates means the loose particle that comes from the burning of forest, that comes from the industry, that comes from the coal burning, and aerosols as well. So you studied that in the second lab as well. So aerosols, particulates. So as beside water vapor, you will see more particulates and more aerosols in troposphere compared to stratosphere, because when you burn something, it will be close to you, it will stay close to you. And since troposphere is the place where we live, is the area where we live, so you will be able to see more of these things in troposphere compared to stratosphere. Then it's saying that for particulates are extremely tiny pieces of solid or liquid matter. And there are some examples that dust. Oh yeah, I've been talking about that. Dust from desert, that's a particulate. Then the eruption from volcanic eruption, there are lots of particulates that is released from the volcano. Then fossil fuel combustion, even from your car when you're driving, when you're burning the fuel. So this emission, that is also releasing some particulates in the air. Then as well as biomass burning. So if you're burning a forest, if you're burning something, if you're burning a wood, that is releasing some particulates in the air. So that is the thing that you see. You will also experience, you will also practice with that in this lab. So that is the real main content, main what do I say, main topic for this lab actually. So both water vapor and particulates are needed for cloud to form. So we will be talking about the cloud formation as well. So you already know that cloud definitely comes from the water. So there's some water and you need some particulates, and these two are used in the formation of cloud. And based on their concentration, we see different types of cloud, as well as we see different types of rain. Like you probably have heard about the acid rain. Why is that? Because when the water is concentrating and making a cloud, there if there is some sulfur with that, in the industrial region, if there is some sulfur within that cloud, then that sulfur, when the that cloud is actually making rain, that sulfur will come to the ground with that rain, and that sulfur creates sulfuric acid, and that is what we know as acid rain. So these are the things we will be talking about cloud formation as well. So next, absorption, scattering, reflection of solar radiation. So you already learned about the solar radiation, the energy that we receive from the sun, that comes in different ways, that is absorbed in different parts of our atmosphere, that is released differently from different objects. So if you look at this diagram, this diagram has two mathematical question for you. So let me take you through the diagram first. So if you look at the Earth's energy balance, the energy balance means the amount of energy that Earth receives, the Earth tries to release the same amount of energy to keep the balance. So we don't need to do much deeper into the energy balance. But if you look at these numbers, first of all, these are the number 341 watt per square meter. That is the incoming solar radiation according to this figure. If you look at that, so the sun is actually sending 341 watt per square meter of energy to the earth. Then this energy is transmitting in different ways. Like, if you look at this number, among these 341, 79 is actually on its way, is actually reflected by clouds and atmosphere, and it goes back to the outer atmosphere again. So among these 341, not all of them reaches the surface. Some of them actually is reflected by the clouds and atmosphere, and some of them are not reflected by absorbed by atmosphere. That is 78. And then it's coming, when it's coming, 23 of them among these 341, 23 of them is actually again reflected by the surface, but 161 of them is actually absorbed by the surface, that hits the surface, that makes the living in the earth. So this is also crucial. So there will be some question about that. There you can see some of these figures. 333 back radiation. Like if the question asks you about that, as far as I know, you won't be asked anything about this one, but it's also relatable. You can, if you study that, if you follow through the figure, you will be able to understand what is talking about. So the main point is, among the 341 that is coming to the earth, 79 is reflected by clouds, 78 is absorbed by the atmosphere, 161 is absorbed by the surface of the earth. It might be the land surface, it might be the water surface, whatever it is, it's absorbed here, and 23 of them is actually reflected. So this is the figure you need to study to answer some of your question. I will take you to that again. So these are the thing I already told you about. The next one. So there's a video about how this reflection, how this absorption happens. I'm not playing the video, but I would highly recommend you to watch the video when you are studying the PowerPoint slide. Then the not this one, sorry. Then the next one, the relationship. So as I already told you about the question 2 and question 3. So the how, let me take you to that question again. So research question 2 and research question 3. How does the composition of the troposphere change with the change in altitude? So how the composition change in terms of altitude, how the composition change in terms of latitude. So this one actually show you the change in altitude. So change in water vapor concentration with a change in altitude. So the more, like, ideally, if you think normally, if you think really in a non-expert way, then you will also be able to understand that uh, when the ocean actually evaporates water, definitely the water will be the most of the water content will be closest will be concentrated towards the ocean, towards the surface, towards the ocean surface. The more you go up from the ocean, the concentration of the water vapor will definitely reduce. So this figure talks to you about that. So if you look at the altitude here, this is the altitude and this is the percentage of water vapor. So if you look at this one, so you see, if the altitude is high, the water vapor is really low. So when it's going down, when the altitude is reducing, it's 11, still the same, 9, 8, still the same, 0.1% probably. When the altitude is really closing to nearing to zero, or in that region, you can see the percentage of water vapor is actually increasing. So the idea is, the more you are, the lowest the altitude is, the highest the water vapor will be. The high the altitude, the water vapor will be less comparatively. Again, the same goes for the pressure as well. If you look at here, this one, if the altitude is low, the pressure is high. The more you go up, the less the pressure will be. So the more you go up, the pressure will be less. Same case here. Either for the low altitude, the water vapor is really high, 1.2%. The more you're going up, the more it's reducing this way. The more you go up, the more it's gonna reduce, and if you can see, it's almost close to zero at a very high altitude. So that is a relationship. So the idea, the bottom line, if you if you increase your altitude, your water vapor concentration, your pressure, your carbon dioxide concentration, your particulates concentration, your aerosol concentration, everything will decrease. The more you go up, it will be decreased again, decreased and decreased. So in here, it will be high in close to the surface where you are living right now. You will be able to see the highest concentration of water vapor, highest concentration of carbon dioxide, highest concentration of aerosol particulates, and so on. The more you are climbing up, if you uh, travel through with a airplane, then you are going far up, and which will actually, in that region, you will see less water vapor, less carbon dioxide, less pressure. The next one, water cycle. So there will be some questions about that water cycle as well. So let me take you through that. But there will be a specific lab related to water cycle. So this lab we won't be doing much of this water cycle, but we will have some of the idea. So first of all, the water cycle, since most of our landscape, most of our earth is covered with oceans, so oceans are the chief sources of water vapor. And then tropical regions, you already studied about the tropical region, you studied about subtropical, you studied southern, northern hemisphere. So these are the regions. So tropical region, where we can see much of the green things, trees and everything, have highest concentration of water vapor because of the greenery they absorb. They takes lots of moisture from the air. And whereas the polar region have the lowest, you can see the polar region where the ice, Arctic and Antarctic, they have the lowest concentration of the water because you can't see much of the green there, as well as lot of, like, most of the water bodies actually in ice formed, so that's why you can see less water vapor there. And then the area with most water vapor moves northward and southward over the course of the year following seasonality. So based on the season, you're like the water vapor will either go up or either go down, like either go northward, either go southward. So the water vapor actually moves this way. I will show you some animation about that, where you will be able to see that throughout the year water vapor actually moves in this direction, like the way I'm moving my pointer, the up and down this way. Yeah, I will definitely show you that one in the lab tour. Oh, sorry. Then about the particulates and aerosols, we've already talked about that. Kind of particulate is soot, smoke, and these are the thing. Industrialized nations, in the industrialized nations, mostly fossil fuel combustion from power plants and cars, such as in the USA, you will see fossil fuel combustion from the cars, as well as there's lots of power plants as well. That also emits lots of particulates. If you look at the Asia, China is the one that has lots of power plants that emits lots of carbon, lots of particulates, and lots of different other aerosols as well. So such nations are in the global north. Mostly when we talk about industrialized nations, we actually talk about the north side of the world, that is USA, Canada, and so on. In the developing nation, if you look at the South America, if you look at the African region, those are the country that we call developing nations, and that countries do not have much of the industries, so they do not have lots of cars. That's why the combustion, the pollution from them aren't actually from the industrial pollution or from the car pollution. They actually produce lots of aerosols or particulates from burning their forest and burning the wood. So you can see mostly from slash and burn to create fields for agriculture, livestock, in the savanna grassland. Developing countries are mostly located in the global south that I've been talking about. Areas with higher aerosol optical depth value have high concentration of particulates. So, what is aerosol optical depth? You will study that in the lab. I'm not going to go into details into that right now. You'll have to do follow the description on your lab. The next one, oh, next one is thank you. So this is the presentation, this is the overview of the presentation and the stuff. So if you follow this, if you clearly followed the instruction from this presentation, I'm sure you will be able to answer 5 or 6 questions already. So let's finish this one, and then I'm recording another video with the lab tour.